So starting with our practice balancing equations on the top of page 2, if I have iron reacting with oxygen to form Fe2O3, this is the formula for rust. So our equation here, we're going to go and fill in the little things that go in the parentheses. Remember, that just represents the state of matter that something is in. So we'll use S for solid, G for gas, L for liquid, and then AQ is our special one for aqueous. So if I have iron, just normal iron, what state is that normally in? Solid, so I'm going to put a little S here. Next to oxygen, what state of matter is that normally? Perfect. And then Fe2O3 is rust. What state of matter is that? Also a solid, so I'm going to put an S there. I just wanted us to get used to seeing these little letters next to the compounds. They have nothing to do with how you'll balance it, but it does matter in terms of what's actually going on in the reaction. So it will come up a lot when we do labs. That'll be starting next week. We'll have a lot of examples of this in real life. So for our first one, if we are going to balance it, at this point, this is what we call our skeleton equation. It just has the correct formulas for all of our reactants and all of our products. Remember that your reactants are what are on your, right now it's on the left-hand side, but we say it's to the base of the arrow, and then the opposite of that is to the point of the arrow. Those are your products. So wherever your arrow is, that's where I draw a little column for yourself, because the arrow is what is showing that you are separating your reactant side from your product side. Everything on this side is a reactant, everything on that side is a product. So over that arrow, I draw this column to show that what's on this side is going to balance with what's on this side. And when we say balanced, what that means is the same number of atoms of each type on each side of the equation. So underneath that arrow in that column that you just made for yourself, we're going to list all of the elements that show up in the entire reaction. So the first element that I have is iron, so I'm just going to write Fe for iron. And then if I keep reading this, the next element that shows up is oxygen, so I'm going to write O for oxygen. Even though oxygen is diatomic, right now I'm just listing the elements themselves, and then out to the side we're going to start tallying. So this is going to be, so use, I call this an R&P chart, reactants and products chart. So the reactants are here, the arrows there are products. Use the R&P chart to count / tally all atoms on both sides of the equation. So this little section down here is what I'm calling the R&P chart. If you don't have room underneath one, so if I ever give you a practice worksheet or something like that, where, I don't know, like right here, for example, if they're all smushed together like this, you can give yourself an R&P chart out to the side, still put your little column there, and then just list, like, I don't know, aluminum, and then iron, and oxygen, and still balance it like this. So if you don't have room underneath it, you don't have to write it underneath there, but I always put this under the arrow so that you see what's on either side. So if you do it correctly, then you only need to really look at one side when you're listing them out, because it should be the exact same atoms that are on your product side. So iron is on my product side and oxygen is on my product side. There's nothing else over here that I need to list. So then we go through and we count separately how many atoms are on each side. So on my reactant side, this side of my equation, I have only one atom of iron, so I'm going to write a 1 next to this. On my reactant side, how many atoms of oxygen do I have? I think I heard it. 2, because there's a little subscript of 2 here, so that tells me I have 2 oxygen atoms. On my product side, how many atoms of iron do I have? 2. And I have how many atoms of oxygen? 3. So your first step is to make sure that you have an accurate count of how many atoms are on either side of your equation. Your second step then is to go through and make them equal each other. So I usually just go from top to bottom, so I'll start with iron. And if I have 2 atoms of iron on my product side of the equation, I need to use whatever coefficients it takes to get this number, this tally, this count, to eventually equal that number. So right now I have 1 iron on my reactant side. I want it to equal 2 irons. So I'm going to use a coefficient in front of the compound that contains iron, or in this case it's just iron by itself, to make that change to 2. So I'm going to use a coefficient right here, and then that coefficient gets multiplied by everything that's behind it in that same compound. But again, this is just iron by itself, so it's only changing that one. So 2 times the 1 iron that I already had changes that tally to now be 2 iron atoms. Now my iron atoms are balanced, and if I move down to oxygen, I have 2 oxygen atoms on one side and 3 on the other side. There is nothing that I can multiply 3 by to make it equal 2, and there's nothing that I can multiply 2 by to make it equal 3. So in this case, I know that I'm going to have to change something on both sides. There's a little bit of guess and check that goes into this, so it doesn't matter completely where you start, but one of the tips that I often give students is if you have O2 on one side of your equation, and that's where all of your oxygens are coming from, you know that whatever coefficient goes here is going to yield an even number of oxygen atoms. So it doesn't matter what number I put here, it's going to continue to be even. You see that? Maybe? Head nods? Okay. On the other side of my equation, I have O3. So is there a coefficient that I could put here to get O3 to produce an even number of oxygens? Two. Okay, perfect. So if I put a coefficient of 2, 2 times 2 iron atoms equals how many irons now changed? 4. So notice that even though I only wanted to change the oxygen, since oxygen is stuck to iron in this compound, I had to change iron as well. 2 times 2 iron makes that 4 iron atoms, and 2 times 3 oxygens will give me how many total oxygen atoms on my product side? 6. So that changes to 6. So even though I had already put in the work and balanced my irons, it became unbalanced because I had to use this coefficient, but that's okay because we can go back and change it. So now I do have a way to get these to equal each other. What coefficient will help me here? Perfect. So coefficient of 3. 3 times 2 oxygen atoms will give me a total of 6 oxygen atoms on my reactant side. And then the last thing I need to do is, since iron is by itself, I can change that coefficient to be exactly what I want it to be, which in this case I need it to equal 4, so I will change the coefficient to 4. So I'll cross that out. And I have 4 iron atoms on my reactant side, 4 iron atoms on my product side, 6 oxygen atoms on my reactant side, and 6 oxygen atoms on my product side. That is what we call a balanced equation. And then the other part that I want you all to be able to recognize is how this will show up for you on a multiple choice question on your test. So one of the ways that we might ask this is, which set of numbers would appropriately balance this equation? And what you have to look for is what numbers would go in the blanks in the correct order. So in this case, your coefficients would be 4, 3, 2. So you would see that listed with commas in between. So 4, 3, 2 would be the one that you're looking for. So this would maybe be a list of numbers, and I'd give you like 2, 3, 4, or 3, 3, 3, or 1, 2, 3, or something like that, and you just pick out the ones that would go in the blanks in that order.